Hello everyone. In this video, we'll continue to cover the temporary life annuity deal, and here we'll establish an expression to get the expected value for this annuity with the relation to the endowment insurance. All right, get back to the N-year temporary life annuity deal. We have this expression for Y, the present value of the annuity. In relation with the insurance, here we relate to the N-year endowment insurance. Let's take a look at the actuarial present value. Z equals nu to the power kx plus 1 if kx is less than or equals n minus 1, or else Z equals nu to the power n. All right, so we will replace the expression nu to the power kx plus 1 and nu to the power n here by Z. Then we get the YZ relationship for the temporary life annuity deal. We still have the relationship here, Y equals 1 minus Z over D. Taking the expected value, the expected value for Z is the actuarial present value of the N-year endowment insurance, the big A, X colon angle N. And here we have the relationship between the temporary life annuity deal and N-year endowment insurance. And then for the variance of Y, this equals 1 over D squared, and then the variance of Z, and we get this expression. All right, let's take a look at an example. Given the following quantities, big AX is 0.14, and then big AX plus 10, 0.215. The period endowment, 10EX, 0.6, and the rate of discount, 0.05. And we are asked to compute a 10-year temporary life annuity deal. Let's take a look at the solution. We need to get the expected value for the annuity, and we are given the expected value for the insurance. So make use of the YZ relationship. All right, so we need to get the actuarial present value for the 10-year endowment insurance, the big A, X colon angle 10. Make use of the relationship. The present value of the endowment insurance equals to the 10-year term insurance plus the 10-year period endowment. We have 10-year X. We need to get the 10-year term insurance. And we are given AX plus 10, and 10-year X. And we can make use of another relationship, this one, to get the present value of the 10-year term insurance. All right, we have the value 0.14 for AX, 0.6 for 10-year X, and then big AX plus 10 is 0.215. From this, we get the 10-year term insurance. The actuarial present value is 0.011. And now we can get the present value of the 10-year endowment insurance. $0.611, and then D is 0.05. Doing the substitution, and upon calculation, we get the answer 7.78. Another example, a portfolio for a group of 50 independent life all at age X. Each purchases a 10-year temporary life annuity deal, annual payments 15. Given the following quantities, the expected value for the 10-year endowment insurance, 0.6, the corresponding second moment, 0.38, and I is 0.05. The insurance company set up a fund with initial amount 6,500. Using the normal approximation, find the probability that the fund is sufficient to make all payments for these 50 individuals. And of course, we are evaluating this at time 0. Okay, the solution. Let Y be the present value random variable for one life. We need to get the expected value for Y. So we need to get the expected value of the 10-year temporary life annuity deal. The annual payment is 15. Given the value related to the insurance, so make use of the YZ relationship, which is 15, and then 1 minus the expected value for Z, and Z corresponds to the random variable for endowment insurance. All right, substitute the numbers, and we get the expected value for Y, which is 126. And then the variance, we have 15 squared, and then 1 over D squared, and then times the variance of Z. We have all these numbers given in the question. Doing the substitution, and upon calculation, we get the variance of Y. The expected value of Y, 126, variance Y, 1984.5. And we have a portfolio with 50 independent lives. Let S be the aggregate present value random variable for the 50 individuals. Using the normal approximation, we need to get the expected value for S, which is 50 times the expected value of Y. And then we also need the variance, which equals 50 times variance of Y. We want to get the following probability. The probability that S is less than or equals 6,500. Convert to standard normal. And using the standard normal calculator, the corresponding Z value here is 0.634921. And then we get the cumulative probability, 0.73726. And this is the answer for this question. That's it for today's video. Thank you for watching, and see you in the next video.